Hello, my dear friends. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for a GATE and ESE preparation. So, very good evening. Good evening. Good evening. I hope everything is good with audio and video. Let me check from mine. Yeah, all good. All good. All perfect. Right? Okay. So, today, because in this Ground Zero series, we have studied three topics: the PERT analysis, the graphical approach in linear programming, and the third one is your basic EOQ model. Okay, so we will be practicing questions from those specified topics so that whatever we have studied, are we able to understand that, are we able to apply that concept very easily? That is very important. Okay, good evening, Gokul. Good evening. My audio and video is all good. All good, all perfect. Any difficulty? Yes. Okay, so let's start the session. And before starting the session, please do share this video to all of your friends so that they could also join this session and they will be having better understanding of this topic that we have already covered in the Ground Zero series. Okay, fine. So good evening, good evening. I hope everyone is fine, perfect. Okay. Now, if I talk about this practice session, like we have covered this ground series. If I try to quickly revise, if I try to quickly tell you what were the topics that we have covered PERT analysis, we have covered the graphical approach, right? And we have covered graphical approach. That too, we are talking about the linear programming program, and we have talked about the basic EOQ model. Fine. So what we'll be doing, we'll be taking the questions from all the three topics, from basic level also, and also we'll be taking the advanced level, right? So that you are able to understand the concept clearly. That is the main objective of this session, right? Okay. So let's start the session. Like you have all connected with me on my Telegram channel. If not yet connected, please do connect as soon as possible because I'll be sharing the PDF. Like yesterday also we had one practice session and I've shared that PDF on that particular Telegram channel. So definitely you can also join with me. It's very simple. You have to just search Mechanical by Suraj Gopi. You'll be getting the first Telegram channel. That's mine only, right? And you can download the PDF. Okay, chalo. Before going to the session, as you know that tomorrow, 26th of March, at 12:30, Rakesh sir will be joining with you guys with a very important workshop because all of you are planning for GATE 2024. So you should be attending this because he'll be giving you the insight what should be your strategy towards GATE 2024, complete 1 year strategy. And the students, those who have cleared the pre-examination, the UPSC ES, Engineering Service pre-examination, there's a dedicated practice course for mains conventional paper. We have will be starting from 3rd of April. So all the aspirants, those who have cleared pre, it's a golden opportunity. You can enroll now with very like next to negligible charges. Like you will be like most nominal charges that you will be seeing. Okay, so please make sure you're registering yourself and get more practice of ESE means. Chalo, so let's start the session and let's talk about what are the different questions that we are talking about. So first question on your screen, consider the following data for a product. So we are having the demand, ordering cost, holding cost in terms of percentage, unit cost, and the time between the order is being given. That orders you need to calculate. So it's a very easy question. Tell me the annual demand they have given. They have given the value of the ordering cost, that is CO. They have given now whenever they are giving the holding cost in terms of percentage and they are not mentioning anything about this. So can you tell me what will be the value of CH? They are saying 10%. 10% of what? Always remember that whenever they are giving you holding cost in terms of percentage, that simply means they are talking about the percentage of unit cost. Is this clear? Percentage of unit cost, right? So I can say it is 10% of unit cost, that is 10 by 100 into 500. That will simply, that will be getting as rupees 50 per unit per year. Okay, so CH value that will be getting is your 50 rupees. So now we got the value of capital D, we got the value of CO, we got the value of CH. This is your CH, right? This is your CH. So we can calculate the value of Q star. So let us calculate from the basic EOQ model the Q star value. Q star is equal to 2D CO by CH root of this. So we'll be having 2 into 1000 into 40 divided by 50 root of this. Can you tell me what is the answer? Because today we'll be having the practice session, right? So tell me what will be the answer. It will be this cancelled out. I will be having 2. We'll be having 40. Yes, are we getting this 40 units per order? That means for economic order quantity, I will be placing 40 units every time. Very good, Saurabh. Very good, Gokul. 40, right? So now in the question, they are saying that what is the time between the orders if your ordering system is based on EOQ? So how we can calculate the value of T star? Anyone? How we can calculate the cycle time? If the orders that you are seeing is 40, so can we say that it is nothing but Q star divided by capital D? Q star divided by capital D. Now what is Q star? That is 40 divided by D is 1000. So from here I'm getting this as 0.04 year per order. That means every order will be having a duration of 0.04 years per order. So is my answer 0.04? It's not the correct answer. Very good, Saurav is correct. Because they're asking the value in days. They're asking the values in days. You have to convert this year into days. So what I'll be doing, you just multiply this with 365. 365 and you are getting this as 14.6 days. So your final answer is 14.6 days. So every order will be having a duration of 14.6 days. Is this clear? Very good, Saurav. Gokul, is this clear? The time between the two consecutive orders will be having a duration of 14.6 days. Like after every 14.6 days, the next order will be coming, and next after 14.6 days, the next order. Okay, so with this way, your EOQ system will be followed the basic EOQ model. So if I try to show you in the help of the diagram, right? If I try to show you in the help of the graph, okay, so the maximum order size that we are placing is 40, right? And it will be coming to 0 after every 14.6 days. 14.6 days, right? Again, the next cycle will be started, then again 14.6 days, and this will be going on throughout the year. Okay, so again 14.6 days, then again 14.6 days, and this will be going on. Okay, fine. So this is basically your basic EOQ model, a very basic question where they have talked about what's the time between the orders. I have framed the questions randomly, like it's not like this in a state will be having only basic EOQ. Might be one question from LP, your graphical, then we'll be having again a question from EOQ. So we have mix and match. So let's see what is the next question. Okay, the question is from PERT analysis. There is a 6 activities. Okay, 6 activities is being given, right? From A to F, 6 tasks is given. So they are asking you, what is the expected completion time of the project? What is the expected completion time of the project? Okay, let's see. So whenever you are getting question like this, what you have to do is, first of all, see, is there any predecessor relation being given? They have directly given the predecessor. So can we draw the network diagram by looking at this table? Quickly draw the network diagram by taking that predecessor logic should be fulfilled. Okay, if I start with task A is having no predecessor. That means you can start task A from the starting first node. But for task B, task A or activity A should be completed, and similarly for activity C, activity A should be completed. So try to draw the network diagram first of all, and they have given the duration for individual activities in this particular column. It is 30, 40, 60, 25, 45 and 20. So they have given the duration of the time and individual activities. Their predecessor is also being given. Try to apply the logic and tell me what will be the expected completion there. That means you have to identify the critical path, then you'll be able to get the answer. Okay, so let's try to draw this network diagram. Okay, fine. So we are having the first activity, a task A. It's from 1 to 2, right? Let's say this is small a. B is, this is your B. It's a 3. This is C. Next is they are saying D after B. Okay, this is 5. B and C. Now, if you see, B and C are having the same starting points. You cannot have directly, you can start B and C from a single node. What you can do, you have to add a dummy in that case. You'll be adding one dummy and you'll be having activity E. You'll be having activity E. And combination of D and E will be having activity F. Okay, so this completes your network diagram. Now let's write the duration for individual activities. Let us suppose this is 30, this is 40, C is your 60, D is 25, E is 45, and F is 20. Okay, quickly tell me what will be the critical path and which activity or which one will be giving you the expected completion time of the project. Option A. Very good, Google. Very good. What is the network? What is the critical path? Which task is lying on the critical path? Tell me in the comment section. So let's start from 0. This is 0. This is 30. 30 plus 40 is 70. 30 plus 60 is 90. Right? So 90. This will be 95. This will be 135. 155. Okay, so the expected time of completion of the project is 155 days, and we are getting this in which one? 1 2 1 2 4 4 5 5 6, or we can say the critical path that we are getting is nothing but ACEF. ACEF is a critical path. And the final answer is 155 days is the correct answer. Option D. Okay, this is, should be day square because the unit of variance is day square. Right? Fine. So in this question, you can easily calculate the expected completion time of the project is 155 days. Now, let us take the second part of this. The second part is the same question. What will be the standard deviation of this project? Now, how we can calculate the standard deviation? If I want to calculate the standard deviation of the project, that will be simply equal to under root of the summation of the variance, and that to which activities? Those are lying on the critical path. Right? Already we have seen that there are 4 activities A, C, E, F. So we are having A, C, E, F. These 4 tasks are lying on the critical path. So I can simply say the standard deviation will be equal to 25 plus 81 plus 36 plus 9. So what is the value that you are getting? Simple. It will be 90. 90 plus 25. So one last will be 1. So under root of 151 days. 151 days. Okay. Fine. So the standard deviation of this particular pathway is coming out to be root 151. And we know that if I want to calculate standard deviation of the project, it is simply the summation of the variance of only those activities which are lying on the critical path. So here A, C, E, F were the 4 activities which were lying on the critical path. Okay, which were lying on the critical path. So from that analysis, we can simply able to identify what is the standard deviation of the project. Root 151 days is the standard deviation of this particular pathway. Is this clear? Right? Okay. Now let's move towards an LPP question. Consider an objective function. We're having an objective function given. This is your objective function 3x1 plus 9x2. Right? And they have given you 2 constraints with a non-negativity condition, that is x1 and x2 greater than or equal to 0. What is the maximum value of this objective function? That means you need to calculate the value of z max. What is the maximum value of this objective function? So whenever you are having this kind of situation, first of all, what you do, you try to convert the constraints into intercept format. So I can write the first constraint as x1 divided by 8 plus x2 divided by 8 less than or equal to 1. This is the first constraint. And second constraint can be written as x1 divided by 4 plus x2 divided by 2 less than equal to 1. So we have written the two constraints in the interset format. Okay. Saurav has given me one answer as 36. Okay, let us cross check whether this is correct or not. Okay, fine. Chalo. So now let's try to plot this. Now let's try to plot this on this graph. So on the horizontal axis, second, we need to have some straight line. Yeah, almost straight line. X1, X2, 8 and 8. Let's say this is 8, this is 8. So definitely we'll be having first constraint like this. And this is less than equal to, so all the constraint towards the origin. This is the first constraint. Second one is having 4 and 2. So this is 4. Let us suppose this is 2. So we are having this. Okay. So can you tell me which should be the feasible region? Or is there any redundant constraint? This is your constraint number 1. This is your constraint number 2. Right. So it is clearly visible that the feasible region will be this one. This one will be the feasible region. So I can simply say the constraint number 1, this constraint number 1 is the redundant constraint, because it is not, even if you try to remove this constraint, right, it won't be impacting my feasible region. It won't be impacting my feasible region. Yes? Yes or no? Hai na? Okay, so let us suppose I'm assuming this as point A, this as point B. What was the objective function? Z max we need to calculate. The objective function was 3x1 plus 9x2. So let us suppose this is point A. Point A is having a coordinate of 0, 2 and point B is having a coordinate of 4, 0. So what's the value of ZA? ZA is coming out to, we put this value of x1 and x2 over here. So it will be 18 and ZB is coming out to be 12, right? 12. So the maximum value that we're getting is at point A. This is the maximum value of this objective function. And where we are getting this value at A. That is your optimal point. This is your optimal value. Okay. Or optimum solution. This is the point where we're getting the optimum solution. So I can simply say the maximum value of this will be simply 18. It will be simply 18. And you won't believe, this is a question of 2 marks from GATE examination perspective, right? Okay, so if you are thorough with the concept, I don't think so it's difficult to get good marks in GATE examination. Okay, so we are getting the maximum value of this objective function as 18, which we have calculated. And here we are also seeing one very interesting part, that is this constraint is which is not even participating in order to identify the feasible region. That means if you try to remove this constraint, then also I'll be getting this region as the feasible region. Then I can say this kind of constraint, we call it as a redundant constraint. Okay, fine. Chalo, let's move to the question number 5. Now let's see who will be giving me the answer. Let's see who will be giving me the answer. Very easy. The ratio of the annual holding cost to the annual inventory cost when the lot size for the order is calculated using economic order quantity model will be. So they are saying that what is the ratio of holding cost to total inventory cost, and that too at economic order quantity. What is the ratio of holding cost to total inventory cost at economic order quantity? Quickly, is it 1, is it 0.5, is it 2 or 0.25? A simple question which you can easily answer if you are thorough with the concept. Tell me one thing, at economic order quantity, what is the relation between holding cost and ordering cost? At economic order quantity, what is the relation between holding cost and ordering cost? Sir, we know that at economic order quantity, both will be having an equal magnitude. Yes, holding cost and ordering cost will be exactly same. And also we know that what is total inventory cost? That is a summation of holding cost plus ordering cost. So can we say this can be written as holding cost plus ordering cost plus holding cost, or I can say holding cost by twice of holding cost, that is 0.5. Option B is the correct answer. Option B is the correct answer. Okay, very good. Gokul, Sora, very good. Option B is the correct answer. 0.5. Okay, fine. So let us suppose if they are asking you what is the ratio of ordering cost to holding cost at EOQ, that will be 1, right? But they are saying that the ratio of holding cost to total inventory cost, that is nothing but 0.5 at economic order quantity. Okay, fine. Chaliye, next question on your screen. Now, again, a question from your graphical approach. Let us see who will be giving me the answer. We are having the objective function, we are having the constraints being given. By looking at this, they are saying the above linear programming is having infeasible solution, unbounded solution, alternate optimum solution, or degenerate solution. That means you have to only see the graph because they're having two variables, so you can use the graphical approach, right? So what you can do is you can try to plot the graph and try to identify what is the feasible region. Are we getting a feasible region? If it is not getting, the answer is infeasible. If you're getting a feasible region which is not bounded, then your answer will be unbounded. You're getting a feasible region, but you're getting multiple points and optimal solution, that will be having option C. And degenerate means one of the variables will be having a zero value in the optimum solution, right? So individual definitions I've just explained you. Try to tell me what will be the correct answer. So let's try to convert this into intercept format. The first constraint can be written as x1 divided by 3 plus x2 divided by 9 greater than equal to 1. Second constraint can be written as x1 divided by 2 plus x2 divided by minus 4 less than equal to 1. Okay, so I have written the two constraints in the intercept format. So now let's try to plot this on a two-dimensional space and try to identify what kind of solution we are getting. Okay, very good. Saurabh has given me one response. Okay, let's try to plot this. Let's try to plot this on the graph and let's see what is basically we are getting. So we are having this as x1, this as x2. So first is 3 and 9. X1 is 3. Let's say this is 3 and this is 9, right? 3 and 9, something like this. Okay, and they are saying that's greater than equal to, that means away from origin, all the points which is located away from origin, right? Away from origin. Or let me draw it a bit far from that. Yeah, now it's perfect. Second is they are saying 2 and minus 4. So this is 2. Minus 4 will be somewhere around here. Minus 4. Right. So 2 and minus 4 will be having a coordinate like this. So they are saying less than equal to. So this would be the feasible region. Right. So if you try to observe, the final feasible region is this one. The final feasible region that we are getting is this one, and this is not a bounded, it is not having a closed boundary. So I can simply say the solution that we are getting is an unbounded solution or unbounded region. Okay, so here I can say the final answer is option B. The solution for this linear programming problem is unbounded. Very good. Okay, the solution for this is unbounded. Very simple and easy question from the graphical approach. Right now, in graphical, it's quite easy when the equations are in front of you, right? When the equations are ready-made in front of you, it's very easy. Only you have to do the pure mathematics. But let us suppose if you're having a question like this, where you need to frame out the objective function and the constraint, that is slightly tricky, or that is which we need to practice. Okay, so let us see what they're talking about. There are two models P and Q of profit which earns 180 per piece. That means profit for P is 100 and profit per Q is 80 rupees respectively. The production time for P and Q are 5 hours and 3 hours respectively, while the total production time available is 150 hours. the total batch size of 40 to maximize the profit, what should be the number of P to be manufactured, right? So whenever you want to frame, whenever you need to frame the equation, there's a simple technique. You just draw a table. You just draw a table which will be talking about all the conditions that they are talking about. Okay, this is capacity. Now, if I talk about the production time, if I say the first condition that we are talking about is production time. Production time. Okay, so for P the production time is 5, for Q the production time is 3, and the what is the total production time ability is 150 hours. That means you cannot go beyond 150 hours as the total production time. That means the maximum capacity is 150. So we got some one of the constraint in terms of production. The second constraint, the total batch size is of 40 units. If I say batch size, if I take it as 1 and 1, so we are having this as 40 units, right? And what is the profit that we are getting? If I talk about profit, per piece profit that we are getting is rupees 100 for P and rupees 80 for Q. Okay, fine. So from here, can we create the objective function? Because this is, we are talking about profit, and that too we need to maximize. So Z max is equal to 100P plus 80Q. This will be your, where I am assuming P number of units I manufactured for model P and Q number of units I am manufacturing for model Q. Okay, so the objective function is 100P plus 80Q. The second, the constraint will be 5P plus 3Q. Maximum value is 150, so less than equal to 150. This is the first constraint. Second constraint, we are having P plus Q less than equal to 40. Okay, so we have created the two constraints, and definitely this P value and Q value will be greater than equal to 0. It won't be having a negative value. You cannot have a negative manufacturing, right? Okay, it will always be having a positive. So all the three requirements for any linear programming we have fulfilled. We have the objective function, we have the constant, we are having the non-negativity criteria. Now we can simply apply the graphical approach to get the answer. Okay, so first constraint can be written as, if I try to plot it over here, if I try to plot this on the second page, this is P, this is Q. So first constraint can be written as P divided by, this will be 30 plus Q divided by, this will be 50 less than equal to 1. This is the first constraint. Second constraint can be written as P by 40 plus Q by 40 less than equal to 1. So let us try to plot it over here. This is 30. Let's say this is 50, right? Okay, very good, very good. Very easy. Very easy. Less than equal to means towards the origin we are talking about. Okay, 40 and 40, right? So let us try to identify the feasible region, and here we are not having any redundant constraint. All the constraint is participating to identify this feasible. This is your feasible region. This is your feasible region. Okay, fine. So let us go. This is point A, this is point B, this is point C. So I can have the coordinate of point A as 0, 40. Now, how we can calculate the coordinate of point B? Point B is the intersection of these two equations, right? So if I calculate 5P plus 3Q is equal to 150 and P plus Q is equal to 40, let us try to multiply it by 3, right? And subtract it, we'll be getting P is equal to 120, 50, 30 by 2, 15. P is equal to 15, Q is equal to 25. So I got the coordinate of point B as 15, 25. Right, so coordinate of point B is 15, 25, and coordinate of point C is 30, 0. So I have identified all the three coordinates. Now objective function is, what is the objective function? Objective function is Z is equal to 100P plus 80Q. 80Q. So we need to check one by one. So ZA, what will be the value of ZA? Place it over here. This will be 3200. Okay. If I talk about ZB, Z will be equal to, this will be 1500 plus, this will be 0 for 2000 है ना, 8 into 25, 16, 4, 2000, that will be 3500. And the last one, ZC, will be equal to 3000. Okay, so I'm getting the maximum value at which point? I'm getting the maximum value at point B. This is my optimum solution. I'm getting the maximum value at point B, right? Or I can say the optimal solution, we are getting at point B, which is having a coordinate of 15, 25. That means when P is equal to 15 and Q is equal to 25, your maximum profit that you'll be getting is 3,500. This is the maximum profit that we are getting, right? So in the question they were asking is, what should be to maximize the profit, what should be the number of P need to be manufactured? So number of P that you need to manufacture is 15. So the final answer is 15 over here. Final answer is 15. Let us suppose they would have asked what is the number of units of Q to be manufactured. Then your answer will be 25. Their answer will be 25. They're asking for Q. Okay, fine. If they are saying what is the maximum profit, then your answer will be 3,500. Is this clear? Understood? Okay, chalo, next question. Now let's talk about a PERT analysis where they are not giving the completion time, right? But instead of that, they're giving you optimistic, pessimistic, and most likely time. Okay, instead of giving the direct time period, they are giving you the optimistic, most likely, and pessimistic time, and they have already given you the network diagram. They are saying what is the critical path duration. That means expected duration to complete this project. Okay, so how we can calculate? So when all the three time estimates given, so we can simply use a very basic approach that activity is following a beta distribution that is equal to optimistic time 4 times of most likely plus pessimistic time divided by 6. Okay, we can use for individual activity. So let's start from this is your optimistic time, this is your most likely time, this is your pessimistic time, right? Okay, so let's try to apply this formulation one by one. So you just need to multiply 4 in this and add these two. So 8 plus 4, 12 divided by, let us write TE. 12 divided by 6 is 2. 24 plus 12, 36 by 6 is 6. 20 plus 10, 30 divided by 6 is 5. 28 plus 14, that will be 42. 42 by 6 is 7. 16 plus 8, 24 by 6 is 4. 20 plus 10, 30 divided by 6 is 5. 24 plus 12, 36 divided by 6 is 6. And the last one is, are you able to see the value? Yes, let me hide myself for 1 second. This will be 12 plus 6, 18. 18 divided by 6 is 3. So you are getting this has to be 2657463. Okay, fine. Now if you try to closely look, it is luckily that we are getting the expected time of completion to be exactly equal to most likely time. If you remember, when we have studied this, we have talked about the activities following a beta distribution. Yes, if you remember, we have talked about this activities following the beta distribution. Let's say this is time and this is the probability of occurrence. Okay, probability of occurrence, right? So it was following a beta distribution like this. It was following a beta distribution like this. Let me draw it like this, a bit opposite of this, right? So this is your most likely time, this is your pessimistic time, and this is your optimistic time. Yes, right? And the expected time of completion always situated near about to TM only. Okay, fine. So that is same thing we have observed over here also. So individual activity we got that expected duration. Let us try to write it over here. 1 2 is having 2, 1 3 is having 6, 1 4 is having 5, 2 5 is having 7, 3 5 is having 4, 5 6 is having 5, 6 7 is having 3, and 4 7 is having 6. Now we need to identify the critical path. Okay, expected duration of completion. So let's start from here. 0, 0 plus 6 is 6. 6 plus 4 is 10. This is 2. 2 plus 7 is 9. So we'll be having 10. 10 plus 5 is 15. 15 plus 3 is 18. So let us go by this way. 5 plus 6 is 11. So 18. So your critical path is nothing but 1, 3, 3, 5, 5, 6, 6, 7. If you see 1, 3, 5, 6, 7 is the critical path that we are talking about, and from here the expected time of completing the project, okay, the expected time for project completion is coming out to be 18 days. It is coming out to be 18 days, right? Fine. So the final correct answer is option D. The final correct answer is option number D. 18 days is the final correct answer. Okay, fine. It's quite simple. Like previously, we have taken an example of PERT analysis where they have given you the exact the TE value directly. But here they just taken one more example where they've given you 3 time estimates. We have to convert that into single time estimate, then draw the network diagram and identify the critical path. Okay, fine. Next question on your screen. Okay, let's see who will be giving me the answer. The total inventory cost at the order of 500 is exactly same as that of the order at 4500. What is the economic order quantity? Now, for calculating economic order quantity, we use the relations or Q star is equal to 2DCO by CH root of this. But in this problem, they are not at all giving you the value of capital D, not even the value of CO, not even the value of CH. But they have given one condition that the total inventory cost at 500 units is exactly equal to the total inventory cost at 4500. Okay, fine. They have given you this condition. So can we apply, and this is not EOQ, this is a simple condition, right? So can we use this condition to get the value of Q star? Yes. And in this question, I'll be explaining a very simple term. In future, whenever you're getting this question, it will hardly take, I would rather say 5 seconds to solve this. Okay. It will hardly take 5 seconds to solve this question. So what this, let us suppose I'm assuming this as Q1 and this as Q2, right? So I can say the total inventory cost at Q1 is exactly equal to total inventory cost as Q2. What is this? Is not economic order quantity, right? This is non-economic. This is for any lot size. So I can say D by Q1 into CO plus Q1 by 2 into CH is exactly equal to D by Q2 into CO plus Q2 by 2 into CH. Taking the similar terms on one side, so I can say D by Q1 into CO minus D by Q2 into CO is equal to Q2 by 2 into CH minus Q1 by 2 into CH. Okay, taking DCO common, this will be Q2 minus Q1 divided by Q1 Q2, right? Is equal to, this will be CH by 2, take it as common. This is Q2 minus Q1. So can we just say this will be cancelled out directly, the numerator part? If this is being cancelled out, I can say 2DCO by CH is equal to Q1 into Q2. If I take root on both the side, under root on both the side, what is this? 2DCO by CH. This is nothing but your Q star. That is equal to root of Q1, Q2. That means now we have got a very important formulation that if the total inventory cost for any lot size is equal to the total any inventory cost for the any other lot size, then I can simply say the economic order quantity will be equal to under root of the product of the two lot size. Is this clear? We can simply get by single line. So here I can simply say what is the value of Q star? Q star is equal to root of Q1 into Q2, that is root of 500 into 4500, that is nothing but this will be 0, 0, 9, 3, 15, 1500 units. Option A is the correct answer. Simple. That means if this condition is being satisfied, you can directly apply this result. Q star is equal to under root of Q1 into Q2. No need to have capital D, C or CS need to be required to get the value of Q star. Okay, fine. So from this particular question, we are able to get a very interesting analysis or result. That means if in an economic order quantity, if the total inventory cost for any lot size is equal to the total inventory cost for any other lot size, then I can say the product of the square root of the product of that will be equal to the economic order quantity. Is this clear? Understood? I hope so. Now you won't be forgetting this concept ever again if a question is coming like this. Fine? Clear hai? Chalo. Next question, the last question. An activity in a PERT network has flowing probability, has following, not flowing, has the following probability distribution associated with the duration of activity with optimistic, most likely and pessimistic time, that is 12, 14. So they have given one graph where 12 resembles the optimistic time, 14 resembles the most likely time and 17 resembles the pessimistic time. Ft is the probability distribution at duration t. What is the probability that this activity would be completed on or before the most likely duration, that is 14 days? What is the probability that this activity will be completed before 14 days? How you can calculate? There's a simple technique. You'll be going for the PERT analysis and you can calculate the value of TE by using, this is your optimistic time, this is your most likely time, this is your pessimistic time. You can calculate by using the formulation, that is TO plus 4TM plus TP divided by 6, right? And this is your schedule time. This is your schedule time, right? Okay, so you can say TS minus TE. So when you calculate, you'll be getting, I think, minus 0.2. Please check. If I try to calculate the TE value, that will be TO plus 4TM plus TP divided by 6. So this will be equal to how much? 12 plus 14. Let me calculate. 12 plus 4 into 14 plus 17 divided by 6, 14.167, right? Okay, and what is the standard deviation? That is equal to 17 minus 12 divided by 6, that is 5 by 6. Standard deviation calculated, TE calculated, this is TS. So you can get the value of Z is equal to TS minus TE by standard deviation. So from here, I am getting this to be 14 minus this divided by 5. So we'll be getting minus 0.2. Now, if I say minus 0.2, that means the probability of Z is equal to minus 0.2 will be somewhere less than 50%. It will be less than 50%, right? Okay, that means option C is not possible, but we don't know the exact value of this. The problem is we won't be able to we can't make a rough guess like it, whether it be 40%, 33% or 20%. If I try to go with a conventional method. So here what we'll be doing, let us try to understand what is this Z value. What is this Z value that we're talking about, right? Or what is the probability of this, or probability of completion? If I want to calculate the probability of completion, right, it is nothing but this shaded area, because they are talking about less than 40. So that means we are talking about this shaded area. So that is nothing but the shaded area. It is nothing but the shaded area divided by the total area. Total area. Let us suppose this is B1, this is B2, right? And this is height H. So what is the area? Half into base into height. Total area half into base into height. So this is nothing but B1 by B. What is B1? That is 14 minus 12. 14 minus 12. What is B2? What is B2? That is 17 minus 12. So this is nothing but 2 divided by 5. That is 0.4. That means 40%. This is a technique. If you don't know the value, we can simply calculate like this. If you are having a triangular shape, normally when you talk about beta distribution, we are having a curve like this, right? So it is slightly difficult to calculate this area, right? Okay, if I talk about the standard normal variate, it's having a curve like this. Okay, this is your capital TE, TS is equal to your Z into sigma plus TE, right? From there only we can get the value Z is equal to TS minus TE by standard deviation. So if I say this is your TS, right? So this is your sigma into Z, right? So this is the shaded portion. This would be the shaded portion. So here we are talking about this as the shaded portion, right? So it is very easy to calculate this area. So shaded area divided by the total area. From here I'm getting this as 40%. The option B is the correct answer. And if you try to calculate for Z is equal to minus 0.2, it will be near about to 40% only. But for that you need to have that table, which is not possible to remember all the values. So you can solve such kind of values. The standard normal variate you can easily calculate by using this proper approach also. Okay, slightly twisted question. I wanted you guys to practice so that you can have more clarity. If this kind of question is coming in the examination, then definitely you should be knowing, because this is a question from mathematics, but by introducing this PERT word, you can say this is a question from industrial and we don't know the concept. So now I think you know the concept, how you can calculate such kind of question very easily. Okay, so this completes your first practice session on the ground zero for industrial. So in the next upcoming weeks, we'll be talking about the more topics from industrial, and once we'll be talking about more topics, that means we'll be having more number of questions for practice, because more number of topics will be covered. Okay, so all if I say 2023 top rankers, definitely they have used the Byjus exam prep in one or another way. So definitely next year we want that you guys to be, your photograph should be there, so that your juniors will be saying your photographs, that how you utilize, how you practice, and how you get a single digit rank in GATE 2024. Okay, and you can get this PDF on my Telegram channel, that is you can download in Mechanical by Suraj, and where you can have more updated information in that channel. Okay, so thank you guys for joining with me. I hope you all enjoyed. This is Suraj Kobi signing off, and I hope so you had a good practice session. So thank you, take care, do take care of yourself, and enjoy your learning with Byjus exam prep. Thank you, bye bye, good night, take care, bye bye.